Welcome back, raccoons. Today we're working on Module 5, Lesson 15. Let's go ahead and get started. Question 1 says, the length of a flower bed is 4 times as long as its width. If the width is 3/8 meter, what's the area? So, with this, we know we're looking for the area. We know that area equals length times width. We know what the width is. The width is 3/8 of a meter. We know that the length is 4 times as long as the width. So we need to figure out what the length is. To do this, we're actually going to use standard algorithm of multiplying fractions. We've done this a whole lot in Module 4, so this shouldn't be anything new to you. So we've got 3/8, and we're multiplying that times 4. 4 written in a fraction looks like 4 over 1. We end up getting 12 over 8 for our fraction. Notice anything about these? They can both be divided by 4 to create an equivalent fraction of 3/2. So our length is 3/2 of a meter. Now, when we're doing area, we know, so let me go ahead and put 3/2. We know we're doing our length times our width. So our length is 3/2 of a meter, and our width is 3/8 of a meter. And what do we get from this? We get 9/16 meters. Don't forget, we have to have square on there. This one was probably the most simple on this problem set. Just to remind you what we did, we noticed it was asking for the area. We had the width. We knew that the length was 4 times that. We multiplied it times 4. Then we reduced that down to create an equivalent fraction that was easier to work with. Then we multiplied the length times the width, and we got our area. All right, moving on to question 2. Mrs. Johnson grows herbs in square plots. Her basil plot measures 5/8 yards on each side. Part A says find the total area of the basil plot. So we have enough information from this first part to answer question 1. It just is asking what the area of the basil plot is. If each side of the square measures 5/8 of a yard, we know that area is length times width, and for this one, so for part A, the length and the width are 5/8. So 5/8 multiplied by 5/8 equals 25/64 yard squared. Part A, done. Part B, this is where we start to get interesting. Mrs. Johnson puts a fence around the basil. You'll notice in your picture you have a square, something like that. If the fence is if the fence is 2 feet from the edge of the garden on each side, so this is her garden, and the fence is 2 feet away, 2 feet away on each side. Noticing that it's saying feet now. We were doing yards, but now it's saying feet. From the edge of the garden on each side, what is the perimeter of the fence in feet? So we need to convert this to feet. So what we end up doing here is we take our 5/8 from the side, so B, we take our 5/8 of a yard, and we need to convert that. So we know that 5/8 yards is 5/8 times 1 yard. 1 yard is equal to 3 feet, so we can substitute that. That ends up being 5/8 times 3 feet, which ends up equaling, remember there's a little invisible 1 down there. So 5 times 3 equals 15/8. And if we broke that down into a fraction, or into a mixed number, we would get 1 7/8 feet. So our 5/8 of a yard is equal to 1 7/8 feet. So when I'm looking back up at this picture, each of these sides are equal to 1 7/8 feet. Now what we're doing is we're adding that 2 on each of those sides. Just to kind of illustrate that, I drew the same figure, but a little bit bigger down here with the measurements in there. So we've got 1 7/8 feet on each side. There's 2 feet being added. So we have 1 7/8 feet plus 4 feet, and that is equal to 5 7/8 feet. So now we know that this whole side right here on the center is 5 7/8 feet. Each side is 5 7/8 feet. So if each side is 5 7/8 feet, then what does that tell us about the rest of the sides? Well, since it's a perfect square, we know that the rest of the sides are also 5 7/8 feet. So when we're doing perimeter, we are adding together all 4 sides. So we could add 5 7/8 feet plus 5 7/8 feet plus 5 7/8 feet plus 5 7/8 feet. But something we know about multiplication is multiplication is just repeated addition. So instead of doing that, we can multiply this times 4. If I go in here and break this down, I can multiply this times 4, and I can actually break this down into both of these. So 5 times 4 equals 20, 7 times 4 equals 28 over 8, because remember the 5 has, or the 4 that we're multiplying has an invisible 1 as a denominator. Now this is an improper fraction. That tells me that there's more than 1 in here. So we actually, to make this make much more sense, we need to divide this out. So 28 divided by 8, 8 can go into 28 3 times. 3 times 8 equals 24. Now we've got 4 still being divided. Remember, fractions are just division, so the 4 is still being divided. So 4 divided by 8, turning that into an equivalent fraction. I know 4/8 is equal to 1/2, so now I've turned this fraction into 3 1/2. 20 plus that 3 1/2 equals 23 1/2 feet. So the perimeter of our shape, I'm going to challenge you to write these in full sentences up here. The perimeter of our shape is 23 1/2 feet squared. Remember, because, oh wait, no, perimeter, not squared, eek, not squared, area is squared. All right, moving on to C. So C is asking us, what is the total area in square feet that the fence encloses? So area is length times width. Our length of our shape with the fence, we determined in part B, was 5 7/8 feet. So our length and our width are 5 7/8. Now, just like before, if you want to do this as the standard algorithm, turning these into an improper fraction, then multiply across the numerator and multiply across the denominator, that's a perfectly fine strategy to use. 5 times 5 is 25. 7/8 times 5 is 35/8, because remember, there's an invisible 1 as a denominator. If you were to convert that into a mixed number, that would be 4 3/8. Same thing here, because it's still 5 times 7/8, so that would be 4 3/8. Over here, we have over here we have 49/64. Wow, that is quite a large fraction. If we add these up, the partial products on the top, we get 29 and 3/8. Adding the bottom ones up, I notice that my denominators are completely different. So what I would end up doing is using my tree, doing 8 and 64. You guys know how to add fractions. We practiced that a lot in module 3 and 4. But just to remind you, create your tree, find your least common denominator, then add those up, convert those into their equivalent fractions, and then add those. What you end up getting, pause the video in case you want to solve that. What you end up getting though is you get 5 and 9/64. Adding these together, we need to multiply this one times 8, which gives us 24. So 29 and 24/64, and 5 and 9/64. Adding those together is 34 and 33/64. Whoa, that is a big fraction. So the total area in square feet of the fence enclosure is 34 and 33/64 feet squared. Go ahead and write that as a sentence in your problem set. All right, problem 3. Janet bought 5 yards of fabric, 2 1/4 feet wide, to make curtains. She used 1/3 of the fabric to make a long set of curtains, and the rest to make 4 short curtains. Part A says, find the area of the fabric she used for the long set of curtains. So we want to make sure we're paying very close attention to what it's asking of us. Now, one of the issues you may notice is it says 5 yards here and 2 1/4 feet there. So our first step is going to be to convert those 5 yards into feet. We know that 1 yard is equal to 3 feet, so 5 yards is equal to 15 feet. So let's first figure out how much fabric she has all together. I'm going to go ahead and set up my area model. Alright, so I've got my area model drawn down here for the total fabric. We've got 15 feet, remember, because that's equivalent to 5 yards, times 2 feet, which ends up being 30 feet squared, and then 1/4 of 15 feet is 15/4, which if you ended up turning that into a mixed number, that would be 3 3/4 feet squared. Adding both of those together, we get 33 3/4 feet. That's our total amount squared. That's the total amount of fabric that Janet bought. Now, for part A, we're finding the amount she used in the long set, which we know that she used 1/3 of the total amount of fabric. So 1/3 of, we know the word of when we're thinking of fractions means that we're multiplying. So we're doing 1/3 of, which usually you would see that if I said 1/3 of the total, you would see that in the front. But with multiplication, we can flip those around and it works well either way. So drawing my little area model, and I have 33 3/4 times 1/3, or 1/3 times 33 3/4. 1/3 of 33 is just 11. 1/3 of 3/4, if we split 3/4 into 3 equal groups, would each have 1/4. So for B, the amount of fabric she used in the long set, remember you're writing this as a full sentence, is 11 1/4 feet squared. So that's the amount she used in the long set of curtains. Let's figure out what she did with each. So the second one says find the area of the fabric she used to make each set of the short sets. So we have to find out each. We know that she made 4 short sets. So for part B, we know that she started with 33 3/4 feet squared of fabric. She used 11 1/4 of that, and she ended up having 22 2/4, also known as 22 1/2, left. So that's what she had left to use between all 4. If we're going to split that into 4 different groups, I want you to think in your head, and pause the video if you need to, but think in your head what fraction you would multiply this by. Alright, so you would multiply it 22 1/2 times 1/4. Give yourself a pat on the back if you got that right. We've got 22 1/2 multiplied by 1/4. Half of 1/4 is 1/8. 22 times 1/4 is 22/4, which is equal to 5 2/4. When we're adding these together, we want to have the least common denominator, which I know right away is going to be 8, but you can build your least common denominator T-chart if you need to. I know it's going to be 8, so this ends up equaling also 5 4/8. Add those together, and each of the short sets took 5 5/8 feet squared of fabric. Make sure you're writing these in sentences for these word problems. Alright, let's get to the last problem. Alright, and we're on to the last problem. So, some wire is used to make 3 rectangles, A, B, and C. Rectangle B's dimensions are 3/5 centimeter larger than rectangle A's dimensions, and rectangle C's dimensions are 3/5 centimeter larger than rectangle B's dimensions. Rectangle A is 2 centimeters by 3 1/5 centimeters. Part A says, what is the total area of all 3 rectangles? Part B asks, if a 40 centimeter coil of wire was used to form the rectangles, how much wire is left? So question B, while it doesn't say the word, it's asking about perimeter. Question A says that it's asking about area. If you take this sentence by sentence, because there's a lot of information to unpack in here, you would see that rectangle A is one size, and then rectangle B is a little bit bigger than that, and then rectangle C is a little bit bigger than that. So they're getting larger. They're getting 3/5 larger on each side each time. So they give us the dimensions of A, which I'm going to go ahead and set up that area model. So they give us the dimensions of A, which are 2 by 3 1/2. So when we're looking at B, we know that it's 3/5. I'm sorry, did I say 3 1/2? I meant 3 1/5. Over here, we know that each length and width are 3 1/2 centimeters bigger than the previous one. So we end up with 2 3/5 by 3 4/5. Please take your time and solve these ones on your own. Pause the video, solve each of these on your own before resuming. For C, we have 3 1/5 by 4 2/3. So those are the dimensions in each of these rectangles. Each of these. Now we need to find the area for each one, but it's asking for the total area of all 3 rectangles. So when we find that area, we're going to need to add it all up. So with rectangle A, we have 6 and 2/5 as our partial products. So that rectangle equals 6 and 2/5 centimeters squared. In rectangle B, the partial products are 6. Over here, we have 9/5, also known as 1 and 4/5. And 2 times 4/5 equals 1 and 3/5. And 3/5 times 4/5 equals 12 25ths. If we add all of those up, go ahead and pause and add all of those up, and then check your answer with me. Remember, least common denominator. So, if we add all of those up, we get 9 and 22 25ths. Wow, that's a crazy fraction. Question, or rectangle C, for each of the partial products, make sure you fill this out. Pause the